In the research process, when you have collected your data, your next step is to formulate a hypothesis. And now when you are on the stage of formulating your hypothesis, the next step is to test the hypothesis. So, we are here to make your task of testing the hypothesis for non-parametric distributions easier. Hello everyone, I am Dr. Shumaila Hassan from the Department of Economics, the Bhopal School of Social Sciences. And in today's module, we are going to cover Introduction to the chi-square test, most popularly also known as the Pearson's chi-square test. Pearson's chi-square test is one of the most commonly and popularly used non-parametric tests. Now, an explanation here to the non-parametric tests. Non-parametric tests are conducted on distributions that do not follow the assumptions of the parametric test, and most specifically, the assumption of the normality of data. If your data is not normally distributed, you will be still in a position to conduct a non-parametric test like a chi-square test. Chi-square test is a statistical tool which is used to determine the relationship between categorical variables. Now let's have a look at what exactly are categorical variables. Categorical variables are those variables wherein you have a title to the category and the frequency related to that particular category. Let's take an example for that. Let's say gender is a category, age is a category, nationality is a category. And if you have in your data collection collected certain frequencies with respect to these different categories, you will be able to conduct the chi-square test. Like I already mentioned, a chi-square test is a statistical method which is used to compare the observed data with the expected data. Let's say, for example, you have collected certain data with respect to a particular sample that you drew from a population, and you already have certain set parameters that this particular variable in a particular population behaves in a certain way. That is known as the population parameter. So therefore, if you are comparing the present sample category characteristics with something which is already existing in the past research, here where the chi-square test comes in handy. And again repeating it, it is only for the categorical data. It is most commonly used in areas like the genetics, the businesses, social sciences and more. The chi-square test basically is of two types. The first type of chi-square test that we conduct is the chi-square test goodness of fit test. And the second one is the chi-square test of independence. Let's have a brief introduction to the goodness of fit test. In our upcoming modules, we will be dealing with the goodness of fit test in more detail. Now let's have a look where do we use and when do we use the goodness of fit test. You can use a chi-square goodness of fit test when you have one categorical variable. It allows you to test whether the frequency distribution of the categorical variable is significantly different from your expectations. That means, is there a statistically significant difference between what you expected out of your sample and what you have actually observed? Often, but not always, the expectation is that the category will have equal proportions. The categories will have equal proportions also means that your expected value and your observed value is exactly the same. This is also the null hypothesis that we construct for a chi-square test. Let's have a quick example for the goodness of fit test. Expectations of equal proportions. Now, how do we divide it into the null hypothesis and the alternative hypotheses? Let's say the null hypothesis would be the bird species visit the bird feeder in equal proportions. Okay, let's say for example, if we are conducting research on different bird species which are visiting the bird feeders at different point of time, are they all equal in numbers? So therefore, this can be categorized as the goodness of fit test under expectation of equal proportions. And the alternative hypothesis to this would be the bird species visit the bird feeder in different proportions. So therefore, when you are constructing the null hypothesis for a chi-square test, it should always be that there is no difference or the proportions are exactly equal. There is one more category under the goodness of fit test, that would be expectation of the different proportions. So, in such a case, the null hypothesis would be the bird species visit the bird feeder in the same proportions as the average over the past 5 years. So, we are comparing a population parameter with the characteristic of the sample population that we have. The alternative hypothesis to this would be the bird species visit the bird feeder in different proportions from the average over the past 5 years. The second type of chi-square test that we conduct is the test of independence. Now, the test of independence, the null hypothesis would be as follows. The proportion of people who are left-handed is the same for Americans and Indians. So, if you are testing the left-handedness of the population of America and India, so your null hypothesis would say that there is no difference between the handedness of Americans and Indians. That means it is irrespective of the nationality. And the alternative hypothesis to this would be the proportion of people who are left-handed differs between nationalities. Let's quickly have a look at the chi-square formula. So, the formula that we use for calculation of the chi-square statistic is chi-square is equal to, now you are seeing two variables here, first is O and the second is E. O is your observed variable, that means the values for the variable that you have actually observed after the data collection, and E is the expected value of that variable, right. And then in the denominator also you see the expected value, right. So, the formula goes as summation of, this is a sign of summation of the observed value minus expected value, you will square it up and divide it by the expected value for that particular variable, right. In the coming module, we are going to see how this chi-square test formula is used for practical purpose. So, therefore, if you are working with categorical variables in research and you feel and you test in fact that the data does not follow the normality distribution or is not normally distributed, you will be surprised to know the results that the chi-square test gives you. Right. It is a very simple test to calculate, and also it has practical applications in genetic, businesses and social sciences and various other researches. It is used to analyze the data and determine the relationship between two categorical variables like we have been talking about in the past few minutes, right. So, therefore, the chi-square test gives you a very powerful statistical analysis tool, and it would be handy when you are using categorical data and you have a hypothesis to test. In our next module, we are going to give you a numerical with respect to both the types of the chi-square test, that is goodness of fit, and the test of independence. So, stay tuned for more.